Hello everyone. In this video, we are going to study about the oxidation of alcohols. Oxidation means the addition of oxygen, or in other way, we can say that the removal of hydrogen is also an oxidation. In this topic, the carbon hydrogen bond will get break and the oxygen hydrogen bond will get break. As a result, these two hydrogen will be liberated in the form of dihydrogen and the carbon oxygen will be converted to carbonyl groups. I repeat, I repeat, the cleavage of oxygen hydrogen bond of the hydroxyl groups and the cleavage of carbon hydrogen bond to which the hydroxyl group is bonded yield dihydrogen and result in the formation of carbon oxygen bond, that is the carbonyl group. Since in this reaction dihydrogen is liberated, therefore this reaction is also called as dehydrogenation reaction, means the removal of dihydrogen. The point to be kept in mind is that primary alcohols on oxidation will always give aldehydes, which on further oxidation will give carboxylic acid. Secondary alcohols on oxidation will always give ketones, which on further oxidation gives a number of carboxylic acid. And the tertiary alcohols will not undergo oxidation reaction because it does not have any oxidizable hydrogen. I repeat, primary alcohols will give aldehydes on oxidation, which further gives the carboxylic acid containing the same number of carbon. Secondary alcohols on oxidation will give ketones, and on further oxidation it will give number of carboxylic acid. Tertiary alcohols will not undergo oxidation reaction because it does not have any oxidizable hydrogen. Talking about the primary alcohols, oxidation of primary alcohols. The primary alcohols upon oxidation with a strong oxidizing agent will always give the carboxylic acid. I repeat, on oxidizing the primary alcohols with a strong oxidizing agent like acidified potassium dichromate or alkaline potassium permanganate will yield the carboxylic acid. For example, in the given alcohol, the hydrogen of hydroxyl groups and one of the hydrogen of the carbon to which hydroxyl group is added and the oxygen from the oxidizing agent. These three atoms will combine to form the water molecule. I repeat, the hydrogen of the hydroxyl groups, the hydrogen of the carbon to which the hydroxyl group is added, and the oxygen from the oxidizing agent will combine to form water molecule and it will result in the formation of aldehyde. Since these two hydrogens are removed, the carbon double bond oxygen formation will take place, which on further oxidation in the presence of oxidizing agent, the oxygen will get added between the carbon and hydrogen to form carboxylic acid. I repeat, the aldehyde so formed from the oxidation of primary alcohol will yield the carboxylic acid on oxidation. On oxidation, the oxidizing agent will provide the nascent oxygen which will get added with the hydrogen to form the carboxylic acid. If the mild oxidizing agent is taken, I repeat, if the mild oxidizing agent is taken like chromium trioxide, so the alcohols will convert to aldehyde instead of acid. means we will get an aldehyde instead of acid. The direct product will not obtain. If we need to obtain the aldehyde from an alcohol in a single step, we need to use the mild oxidizing agent like chromium trioxide. Similarly, Similarly, if we use a mild oxidizing agent like pyridinium chlorochromate, which is also called as the Collins reagent. I repeat, the pyridinium chlorochromate (PCC) is also called as the Collins reagent, which is mainly used to obtain unsaturated aldehyde from unsaturated alcohol. That means the PCC, the Collins reagents, will not affect the double bond. It will simply oxidize the hydroxyl group to the aldehyde group. So, in order to obtain the unsaturated aldehyde from unsaturated alcohol, we use PCC, that is pyridinium chlorochromate, which is also called as Collins reagent. The secondary alcohols on oxidation with a strong oxidizing agent will give the mixture of carboxylic acid. For example, if we have propyl alcohol, if we have propyl alcohol, the hydrogen of hydroxyl groups and the hydrogen of the carbon to which the hydroxyl group is bonded will combine with the oxygen provided by the oxidizing agent to form the water molecule. I repeat, the hydroxyl groups will replace hydrogen and the carbon to which the hydroxyl group is bonded will remove the hydrogen, and both the hydrogen will combine with the oxygen, nascent oxygen provided by the oxidizing agents, so they will form the water molecule. As a result, carbon double bond oxygen formation will take place, and in this case it will be the ketone. Ketones on further oxidation will give the mixture of acid. I repeat, in secondary alcohols, the secondary alcohols will yield the ketone carbonyl compounds containing the same number of carbon, and the ketone on further oxidation will yield the mixture of acid as a final product. Secondary alcohols when treated with mild oxidizing agent like chromium trioxide, so they will give the product as ketone as given in the chemical reaction. Here the hydrogen of this carbon and the hydrogen of hydroxyl group will get removed and they will yield the ketone. Since we have studied in the starting of this topic that this reaction is also called as dehydrogenation reaction. Dehydrogenation can be carried out in the presence of copper when the alcohol is heated at 573 Kelvin. Here the alcohol's vapor is treated with copper at 573 Kelvin so that they can be converted into their respective compounds like the hydrogen of hydroxyl group in primary alcohols and the hydrogen of the carbon to which hydroxyl group is added will get removed and it will be in the form of dihydrogen, resulting the product as aldehyde. Similarly, if we remove these both hydrogen in the form of dihydrogen by heating the alcohol in the presence of copper at 573 Kelvin, the dihydrogen will get removed and the carbon double bond formation will take place. that is the ketone. Talking about the tertiary alcohol does not undergo dehydrogenation reaction. Instead, it will remove the water molecule from itself, like the hydroxyl group and the hydrogen of one of the alkyl groups will combine to form water, and the double bond formation will take place. I repeat that tertiary alcohols does not undergo oxidation reaction or the dehydrogenation reaction because they does not have any hydrogen freely bonded to the carbon. So it will simply remove the hydroxyl group and one of its hydrogen from the carbon chain in the form of water molecule, giving the alkene as a byproduct.